So let's have a look at reliability and dimensionality. Now, it's important to note that reliability applies to only one dimension, or trait, or characteristic. And we have a problem with Cronbach's alpha because it tells us nothing about the number of dimensions involved. So let's take, for example, love or attraction or disgust, racism, freedom. Are they one-dimensional? That's highly problematic. There are techniques which are large sample techniques which attempt to discover the number of dimensions or factors or latent variables which are behind a number of items. Factor analysis and principal components analysis are the ones that come to mind. But bear in mind that these are large sample techniques, and as a rule you want at least 200 in your sample. We want to see what you can do with small samples. So this is an example of a questionnaire on euthanasia which I gave to 11 nurses. And stop the video for a moment and see if you can work out how many dimensions are behind these items. Well, this is what I assumed. I've grouped the green ones, the pink ones, and the blue ones. And there's one, which is item E, which kind of stands out, which I wasn't sure where it would go. But let's rearrange this. So that you can see the green ones tend to be very general in terms of attitudes towards euthanasia. The blue ones are rather about the legalistic questions, and the pink ones relate to the way other people feel about other people. Maybe to what extent do they sympathize or empathize? And E, as I said, is one which I couldn't quite place. I wasn't sure about where I would put this. Now, the two references which you can look up to find the theory behind this, Hunter starts it off, and Steenbergen was very useful, I found, to doing real analysis of this. So we're going to be looking at similarity coefficients, and this is Hunter's original formulation based on correlation coefficients. So the similarity coefficient is limited, bounded in the interval -1 to 1. Now, I used Steenbergen's similarity coefficients here to show what happens if we assume that there are 3 main factors or traits behind the items. Now, I've kept the same color scheme here to show how the items hang together on their own block and how they relate to other blocks. So just to give an example, look at the first column relating to block 1. You can see the 3 items, the 3 first items in the green area, all have very high correlations on that block. But the next lot, the blue items on block 1, are all negatively correlated to that block. This is an impression we get of the weighting of each item on each block. Let's move on. Just to remind us that the green refers to the generalized attitudes towards euthanasia. The blue area is legalistic, and the third one has to do with compassion, maybe, the way people feel about other people's rights to euthanasia. And here it is schematized in a different way. These are the scale-wise similarity coefficients, which effectively show us both internal consistency. Now that is on the main diagonal, and external consistency, which is off the main diagonal. So the main diagonal should all have highly positive readings, as close as possible to 1. That would be an indication of internal consistency. Remember, the interval goes from -1 to 1. All the external consistency indicators off the main diagonal should be as close as possible to 0. So if you look at this for a second, you may have to stop the video. Look at this for a second, and we can see one thing here which is not very good. You may have spotted it, you may not have. But this indicator of the third grouping on block 1 is very high. It's unacceptably high, and notice how it's higher than the internal consistency similarity coefficient, scale-wise similarity coefficient, relating to the second block. It's actually higher than that. Well, this is just not acceptable. And what we've done here is we've eliminated the second group, the negative grouping, which was related to the legalistic attitudes, and we've put together all of those very highly correlated indicators. Here we have a scale-wise similarity coefficient of 0.908. This is what we're doing here, is we're assuming that all of these items are indicators of one trait or one dimension. Now you'd similarly get a very high alpha coefficient reading for this. In this case we've got 0.908 as our reading. This is an assumption that there are two blocks, in fact. We've got the same groupings, leaving out the legalistic ones, but we've assumed there are two. But you can see just how high all of these readings are. The two blocks don't really get separated. And this is the proof of this. When you look at it, the scale-wise similarity coefficients, it's just all extremely high readings. This would tend to indicate that there is only one dimension operating here. But this is a question of common sense. This is a question of reading, whatever reading you want. Now this is some important theory to bear in mind. First of all, the Likert scale is ordinal. You should use polychoric correlations to deal with this kind of scale. However, programs are very expensive to do polychoric correlations, but Ekstrom has argued that you can use Spearman correlations because in practice they tend to approximate each other. So let's look at how we can calculate the similarity coefficients using Steenbergen's Unisim program. Now, as you can see, it's a very simple one, and the file we're going to use is called Euthanasia block code, which is in Notepad, a very simple form. It has to be in Notepad, I think. And the important thing to notice is that you can't just type in the data. You have to have a file which you then load into the Unisim program. This way: File, Open Data. It's called Euthanasia block code. And it's in there, but you don't know it because nothing shows that it's in there. Okay, it wants to know what the structure is. How many items are there? There are 10 items. Next, go to the number of blocks. Well, we've decided we're going to have 3 blocks. So, let's put that in. How big are the block sizes? Well, it's 3 for the first block, 3 for the second, and 4 for the third. I've thrown in E, the one that I thought was more or less independent, with the third block, just to see how it performs. Let's compute using the parallel or semi-parallel option. It's done. We don't know it because it shows nothing. But, as if by magic, It all comes out. The similarity matrix is there. Item-wise similarities, which show the weightings of the items on the 3 blocks, which I've already shown. And the scale-wise similarities, which I've also already shown. But that's how you do it. And you have to mess around with this a bit, decide how many blocks you want, what you're going to leave out, what you're going to put in, and how you arrange them. That's up to you.